In this video, we are going to discuss about what is lightning really. The science will shock you. Have you ever seen a flash of light streak across a stormy sky? That's lightning, nature's most powerful spark. Think of it as a giant version of the static shock you get from touching a doorknob, but millions of times stronger. Lightning forms inside towering cumulonimbus clouds, which are like giant atmospheric blenders swirling with moisture, ice, and air. As ice and water droplets collide, they exchange electrons, creating a separation of electrical charges. The top of the cloud becomes positively charged, while the bottom becomes negatively charged, turning the cloud into a massive battery. This imbalance builds up enormous tension, with the negative charge at the cloud's base seeking a positive target. Often, that target is the ground, which becomes positively charged during a storm. This sets up a powerful attraction between cloud and ground, priming the sky for a dramatic electrical discharge. When the tension is too great, lightning strikes, releasing all that stored energy in a brilliant flash. It's pure physics happening miles above our heads. Lightning is both beautiful and a reminder of nature's raw power. Inside a thunderstorm, powerful updrafts and downdrafts create chaos, with particles constantly colliding. This violent mixing charges the cloud, much like rubbing a balloon on your hair. Heavier Grauple particles become negatively charged and sink, while lighter ice crystals become positively charged and rise. This sorts the charges, negative at the base, positive at the top, polarizing the cloud. The voltage difference can reach millions of volts, storing immense energy. A single storm can build this charge in just minutes. The air acts as an insulator, but when the charge is too great, the air breaks down. That's when lightning is unleashed, releasing all that built-up energy in a split second. The process is fast, powerful, and awe-inspiring. All it takes is the right conditions for the sky to light up. Not all lightning is the same. There are several types, each with its own story. The most familiar is cloud-to-ground lightning, the classic bolt that strikes Earth and poses real danger. Cloud-to-cloud lightning jumps between separate clouds, lighting up the sky without touching the ground. Intra-cloud lightning, the most common, flickers within a single cloud, making it glow from within. High above storms, rare types like sprites and elves flash in the upper atmosphere. Sprites look like ghostly jellyfish, elves like expanding rings. Positive lightning, though less common, is far more powerful and can strike miles from the storm, even under blue skies. These bolts start from the cloud's top and can travel long distances. That's why lightning can strike far from where it's raining. Each type is a reminder of the complexity and unpredictability of storms. Lightning is more than just a flash. It's a fascinating display of nature's variety. Lightning is a giant spark, but how does it travel through air, which usually resists electricity? It starts with a stepped leader, a faint zigzag path of negative charge reaching down from the cloud. As it nears the ground, positive streamers rise up from tall objects trying to connect. When they meet, a powerful surge of electricity, called the return stroke, blazes along the path. This heats the air to over 50,000 degrees Fahrenheit, hotter than the sun's surface. The rapid heating causes the air to expand explosively, creating a shock wave. That shock wave is thunder. Lightning and thunder happen together, but we see the flash before we hear the boom because light travels faster than sound. To estimate a storm's distance, count the seconds between flash and thunder, then divide by 5. Lightning and thunder are two sides of the same electrifying event. It's a dramatic show of energy and sound. Lightning is awe-inspiring, but it's also dangerous. The best safety rule: when thunder roars, go indoors. If you hear thunder, you're close enough to be struck. Once inside, avoid windows, electrical appliances, and plumbing. Lightning can travel through wires and pipes. A sturdy building is safest. A hard-topped car is a good backup. If you're caught outside, avoid open fields, tall objects, and water. Crouch low, feet together, but never lie flat. Spread out if you're in a group to reduce risk. And remember, lightning can strike the same place more than once. Tall buildings like the Empire State Building are hit dozens of times a year. Understanding lightning helps us stay safe and appreciate its power. Science explains the storm, but respect keeps us safe. Even in a thunderstorm, knowledge is your best protection. If you enjoyed learning about lightning, don't forget to like, subscribe, and share this video for more amazing science content.